The modern power grid is a massive, interconnected machine. We rely on it for every drop of water and dollar we spend. A cascading failure here stops the entire supply chain instantly. Most traditional preparedness focuses on stockpiling canned food, bottled water, and basic camping gear. This is a passive defense. This approach assumes that a blackout is a temporary disruption. It relies entirely on the expectation that centralized systems will eventually be restored by an outside authority. Real survival leverage comes from a specific set of commercially available, unregulated technologies that operate entirely outside the centralized infrastructure. These tools grant an average citizen manufacturing, surveillance, and communication capabilities that were previously restricted to military forces and state actors. Acquiring this equipment is a methodical process of decoupling your survival from systems that are prone to failure. The process begins with local production. A 3D printer functions as a personal, off-grid hardware store, capable of creating essential components without a commercial middleman. When a generator component snaps or a vehicle requires a specialized bracket, you can manufacture the replacement part on site. You no longer need to wait for a shipping industry that has ground to a halt. Digital libraries contain billions of open-source schematics. These files serve as the blueprints required to recreate almost any physical tool or mechanical part. By converting a digital file into a physical object, you maintain a logistics cycle completely independent of the commercial grid. This self-contained manufacturing process leaves no digital or physical trail for external oversight. There are no taxes to collect, no shipping routes to monitor, and no centralized records of what you own. Bringing this capability offline changes your relationship to the economy. You transition from a dependent consumer to an independent manufacturer. Physical security requires environmental control. In a total blackout, zero visibility is an immediate threat to anyone without the means to see in the dark. While this capability was once limited by massive defense budgets, commercial manufacturers now produce military-grade optics that are accessible to the public. Thermal imaging provides an even greater advantage. This display shows how sensors detect body heat directly, exposing targets through darkness, dense vegetation, and standard camouflage. This environmental awareness is extended through the use of small drones weighing under 250 grams. Because these platforms fall below the 250-gram threshold, they currently bypass the federal registration requirements mandated for larger aircraft. Deploying these drones pushes your visual perimeter miles beyond your immediate location, converting unknown movements into actionable intelligence. The efficacy of this technology is proven in modern drone warfare. Small platforms provide constant reconnaissance, allowing for high-speed precision strikes against targets that cannot see them coming. Controlling both the airspace and the darkness eliminates the element of surprise. It removes the tactical advantage typically held by larger, organized groups. A grid failure immediately severs standard internet and cellular communication, leaving most households in total isolation. Satellite internet provides the primary connection for an off-grid command center. As long as you can provide local power, you maintain access to global data. For local coordination, the Android Team Awareness Kit, or ATAK, allows teams to map and track one another's positions completely offline. Pairing low-power computer boards and encrypted radios creates a localized mesh network. Devices communicate directly with each other, ignoring dead cell towers. This allows secure transmission of drone feeds and mapping data, managed through a private server. This architecture is functionally identical to the systems used to stream real-time data from drone operations in Afghanistan to command centers in the United States. Operating a private data hub ensures that a local community remains coordinated even during a total information blackout. The integration of these capabilities creates an individual who can sustain manufacturing, miles of terrain in the dark, and communicate across a private grid. Institutions are increasingly focused on regulating these specific consumer goods, precisely because they provide such high levels of independence. This friction is the predictable reaction of a centralized system realizing it can no longer enforce a monopoly on your survival. This level of preparedness functions as a calculated strategy for reclaiming the personal leverage typically surrendered to utility providers and the state. Real autonomy is achieved by owning the technical architecture that allows your survival to continue, regardless of whether the central system is functioning.